Alright, so in this video we're going to take everything we've learned so far and tie it into one big example. So for this example we're going to be working with McDonald's drive-through wait times. It's normal, mean of 91 seconds, standard deviation of 26 seconds. So we're given our mean and our standard deviation that we're going to need. So our first question is to use the normal curve rule only. So we can use that 68, 95, 99.7 rule. You're going to find the approximate probability of a customer waiting at least 117 seconds to receive their order. Alright, so I'm just going to start with my picture like we do with pretty much every example that we've done. And go out my 3 standard deviations in both directions. Put our numbers on here. So there's our mean of 91, subtracting off the 26 as we go left, adding on 26 as we go right, and it says we want 117 or more, at least 117. So I would want everything to the right. Remember, I can't use the table here, I can only use the normal curve rule that I know. So here's what I know. I know that if I go out 1 standard deviation in either direction of the mean, I get 68% of my data. So I have 68% between those two numbers. I have 32% left to put on. I'm going to split that up. So this is going to be 16%. And then this is going to be 16%. And look, I already have my answer. So then I can say there is about a 16% chance that a customer waits at least 117 seconds to receive their order. Part B, it doesn't say we only have to use the normal curve rule, so I can use pretty much anything I want now. What is the probability that a randomly selected customer must wait for longer than 2 minutes after ordering? Alright, so again I'm going to start with my same picture. So the first thing to be careful of is 2 minutes. I was talking seconds up here, so I better make sure my units match. So 2 minutes is 120 seconds, which will fall about here. And we want longer than, so we're going to shade to the right. Now if I just want to kind of compare this to above, I'm a little bit higher than 117. So up here there was a 16% chance. So I know this is actually going to be a little bit smaller than a 16% chance. Since I'm trying to find a probability, we're going to be working with the Z equals formula. So my Y is the 120. Our mean is the 91. And our standard deviation is the 26 seconds. So I get 1.12. We're going to take that value to the table. Well, here we're working from the outside in, right? This one I have a Z score. So that's a number here on the outside of the table. So I'm going to look for the 1.12. And I get 0.8686. But remember, that tells me what's to the left of the mean. So technically, if I'm looking at my picture here, that's this side. So on this one, since we're shaded right, we have to use that 1 minus rule. So take 1 minus what we actually just found. therefore, so this little piece here is going to be 0.1314. So then we can say the probability that a randomly selected customer waits at least 2 minutes is our answer we just found of 0.1314 or 13.14%. Now we want to find what amount of time do 20% of drive-through customers wait less than. So again, I'm going to start with my picture. Alright, so 20%. Here I can actually ballpark this one from here. So right, so 16%. So like that exactly one summation away on either side here. And we want the weight less than, so there's 16% to the left of 65. So I know it's going to be a little bit further over to find that number. Again, you don't have to add that to your picture with the little increments at the bottom for these types of problems. But we want this to be 20%. Our goal to find that number at the bottom. So this time, since we're trying to find this number at the bottom, we use our other formula, the y equals formula. So I already know sigma, I already know mu, I need to find z. This is where we go to the question mark, ask ourselves how much is to the left of the question mark. So we're going to be going looking for 0.2000. Notice I know that my z-score is going to be negative, so I know I'm below the mean. So we're going to look for 0.2000 on the inside of my table here. So I find closest thing looks like it's this 0.2005. But again, that's just our actual probability. I need to use that to find my z by finding the row and column. So it is negative 0.84. So we have our z. So now we can plug everything back into our formula we have. So our z is negative 0.84. Our standard deviation we know is 26 seconds. Our mean is 91 seconds. So we're going to get about 69.16 seconds. So we can say that 20% of our McDonald's drive-through customers wait less than our 69.16 seconds. Right, for D, we want to find the probability that they wait less than 60 seconds or more than 100 seconds. So again, draw the picture is our first thing to do. So you can pause it here and try that. Alright, so this is what your picture should look like, because we want less than 60 or more than 100. So right now, if you look at this picture, we haven't really done anything exactly like this, but if you just pretend that you were just trying to find this piece, you would know how to do that. If you were asking yourself just to find this piece, you would know how to do that. So let's treat them as two separate problems. So let's treat this one as like part A, and this one as part B. We're trying to find a probability, so we're going to be using that z equals formula. So on this side, we're going to be using the 60 for our y. Mean and standard deviation haven't changed at all. So we get negative 1.19. We're going to take that number to our table. there's negative 1.19. Remember, the table shades left. The good news is this piece for part A also wants shaded left. So for this piece, that is our probability. So that is this piece. Now let's do a similar idea for the other piece. Again, we're going to start by finding our Z. This time, our number for Y is just 100 instead. But mean and standard deviation have not changed. This time our Z is 0.35. We're going to take that number to the table. So there's our 0.35. So we get 0.6331. But remember, that's what's to the left of the number, right? We want what's to the right of that number. So for that, once that piece is shaded right, we have to do our 1 minus rule. So we get 0.3669. I apologize, I got off there. So there's our 0.5. So it should have been 0.6368. I apologize, even I do make mistakes sometimes. Let me change that. So just a little off here. So it should have been 0.6368. Got off a column there. That part should have been 0.3632. Alright, so that would be part B piece over here. But notice we only want one answer. So we have these two separate pieces. So what can we do with it? Well, we're just going to add those two pieces together. So our overall probability will be 0.1170 plus our 0.3632 we just found. So we're going to get an overall probability of 0.4802. So then I can say the probability that a randomly selected McDonald's drive-thru customer waits less than 60 seconds or more than 100 seconds is our 0.4082. Alright, now we want to find the probability that a randomly selected McDonald's drive-thru customer waits between 40 and 85 seconds. Alright, so I would actually try to pause it here and try to work the entire problem and see if we feel good. And of course, I will work the problem and we will stop and explain it as well. Alright, so let's see how you did. So our picture, we're shading between 40 and 85. So we had to find each of our z-scores separately. So one for the 85, the other one for the 40. With both numbers, we went to the table. Then, since we were between, we had to take our two numbers and actually then subtract them, and should have got 0.384. So then last we're going to say our probability that a randomly selected McDonald's drive-thru customer waits between 40 and 85 seconds is 0.384 or 38.4%. Alright, our last question. Suppose Wendy's also are normally distributed with a mean of 117 seconds and a standard deviation of 32 seconds. You want to figure out what would be more unusual, 120 seconds for McDonald's or 150 seconds at Wendy's. Now, you don't have to draw the pictures for this one, but again, can sometimes help for understanding. So I'm going to start with a McDonald's picture here, because that's what we've been working with. And they have a wait time of 120 seconds. And we're going to compare that to Wendy's. But different mean and different standard deviation. So I'm going to make sure I draw their picture accordingly. So their mean is 117. And I got to use this 32 as I'm going out in my increments here. And their wait time was 150 seconds. Alright, so they're both just a little bit more than one standard deviation above. We're trying to figure out which one is more unusual. So what does it mean to be more unusual? We're supposed to be further away from the mean. Now, why I have, again, the kind of those quotes around the further here is because we need to also take into account standard deviation, because they do have different standard deviations as well. So what I'm looking for then in my z to answer, that's going to tell me whichever is z. And I can say z here because that already takes into account the different standard deviations. So whichever z is further from 0 is going to be the more unusual observation. So let's find the z for our McDonald's time. So we're going to take 120 minus its mean divided by its standard deviation, and we get 1.12. Let's do the same thing for our Wendy's time, but using, of course, its mean and its standard deviation. And so I can do that. And this is actually all I need to look at to answer my question. I don't need to go to the table at all. This goes back to the very first types of examples we did in the normals packet 1. All we can do is compare these two z-scores and know exactly which one's more unusual. Since this one is further from 0, the McDonald's time is going to be more unusual. So whichever one is further away, in a sense, whichever more standard deviations away, is the one that's going to be more unusual. So I can say that the McDonald's time is more unusual because it is more standard deviations away from the mean than the Wendy's time. So that's our big example here. If you have questions on it, please make sure you come prepared with questions to see me.